Have you ever pondered the mysteries of the universe, the celestial bodies that reside within its vast expanse, and the fascinating phenomena that occur when they collide? The universe is a stage replete with drama, suspense, and grand spectacles. Its actors, the stars, the galaxies, the black holes, and the neutron stars, all play their parts, weaving narratives of cosmic proportions. Imagine, if you will, a cosmic ballet, where the dancers are not just moving with grace, but also with unfathomable power. A black hole, the epitome of irresistible force, and a neutron star, a bastion of unyielding matter, locked in a gravitational pas de deux. Their dance is not just a show of elegance, but also a testament to the raw power that pervades our universe. The stakes are high, the tension palpable. What happens when an unstoppable force meets an immovable object? Today, we're going to delve into one of the most captivating and destructive events in space, the collision of a black hole and a neutron star. To understand the magnitude of this event, we first need to comprehend what black holes and neutron stars are. Picture a black hole, a region in space where gravity is so potent that it swallows everything, even light itself, into an inescapable abyss. Now, envision a neutron star, the ultra-dense vestige of a massive star that once exploded in a supernova. This cosmic relic, although small in size, packs a punch with its incredible density and rapid spin. Black holes, with their insatiable hunger, and neutron stars, with their unyielding resilience, represent the extreme ends of gravity's power. They are the universe's heavyweight champions, each possessing unique and formidable properties. When a black hole meets a neutron star, it's not just a clash of titans, but a collision of unimaginable forces that reshapes the very fabric of space-time. Imagine the ferocity of an encounter between these two celestial giants. Now that we've grasped the nature of black holes and neutron stars, let's imagine what happens when these two celestial forces collide. Picture this, if you will, a black hole, a celestial object with a gravitational field so strong that nothing, not even light, can escape its voracious maw. And then, a neutron star, the densest and tiniest stars in the known universe, with the mass of about 1.4 times that of our Sun, but with a diameter of only about 20 kilometers. Now imagine these two titans of the cosmos locked in a deadly dance of destruction. The black hole, like a cosmic predator, begins to pull at the neutron star with its immense gravitational force. The star, in its final throes, starts to stretch and distort, a process known as spaghettification. This isn't a gentle pull, it's a violent cataclysmic event that tears the star apart atom by atom. As the star is ripped to shreds, it releases an incredible amount of energy, resulting in a bright flash of light. This light is so intense that it can be seen from billions of light years away. But the destruction doesn't end there. The remnants of the neutron star are sucked into the black hole, adding to its already immense mass. But what's truly mind-boggling is that we, on our tiny blue planet, can detect these cosmic cataclysms. When black holes and neutron stars collide, they create ripples in the fabric of space-time, known as gravitational waves. These waves travel across the universe at the speed of light, and when they pass through Earth, they cause a minute but measurable stretching and shrinking of space itself. The detection of these gravitational waves has opened up a new way for us to study the universe. It's like we've been given a new set of eyes, allowing us to witness events that were previously hidden from us. So, the next time you gaze up at the night sky, remember the cosmic ballet of destruction and rebirth that's taking place far beyond our sight.